Do you want to learn about the differences between a UPS and a power station? Would you like to learn about how a power station works? Well, stay tuned. I'm going to show you how to build that foundation. Welcome to another edition of Tech Bites with Ron Nutter, your home for all things relating to smart home technology. In this episode, we're going to talk about how to create your own power wall or power station. Hi, I'm Ron Nutter, and we're going to be working on this together. This content is also available as an Amazon flash briefing or podcast. Please go to techbiteswithronnutter.com for more information. For any items mentioned in this episode, there are affiliate links in the description. If you click on these links, I will get a small commission, but that won't affect the price you pay for the item. If you want to get notified when new content is uploaded, please click on subscribe and enable notifications. Here's what we're going to be covering in this video, and that's how to set up your own power station. And a lot of this will transfer into being a power wall as well. First, the difference between a power station and a UPS. We'll talk about the required items. Fair warning, there's going to be a little bit of a list to this one. We'll talk about assembling the power station and then looking at some potential upgrades that you can do once you're comfortable with this up and running. Well, to get started, first we need to kind of get some of our terminology agreed to so that we all have the proper understanding moving forward. Now, the two things you're probably going to hear about the most, power stations, which has been a lot of talk about that lately, and UPSs. Main difference I can tell you up front is the UPSs, you're on AC power all times unless there gets to be a brownout or a loss of power, and then the UPS switches over to battery. That should be fairly seamless. You really shouldn't lose power on your devices, but you're going to hear relays click, and you depending on your UPS. So there is going to be, it may make a little noise once in a while. Your capacity is going to be somewhat limited as a general rule. Most UPSs, unless you get into the higher end ones, are not expandable. So whatever battery capacity you've got going into it, then that's going to be what you're stuck with. Where with the power station, to an extent, you can add batteries to it. You may have to change out some of your wiring from the batteries back into the fuse block or whatever you're using to handle the distribution of power. And you're going to make sure that as you increase the number of batteries, your amperage will increase. So if your power draw is going to be increasing, that's something you need to think about, but we'll get to that down the road. Power stations you also heard the term maybe power wall, and this gets into a much larger situation to where you're going to have either rows of batteries in some sort of case mounted to the wall, or you may have just complete modules. Tesla is one of the ones that you just put the module up on the wall and you pretty much are good to go. Now, the power stations are portable. Is some expandability with those. What we're going to be talking about in this one is getting a basic power station up and running, and then we can start looking at all the expandability options you've got with adding batteries, adding charge monitoring or power monitoring of the battery. It's not just as simple as putting a voltmeter onto the battery to find out where the charge is, because it really is not going to tell you that much. And then also looking at adding solar. But again, those are subjects we'll do later in the video, but there's a lot of expandability. So let's start going over what's going to be involved in getting this basic power station up and running. Now, I mentioned early in the video that this was going to be a little bit of a list this time, so feel free to review this several times, and you may need to stretch this out over several different orders so that it doesn't break the bank. Now, the first thing we're going to be looking at is the battery. I went with a 50 amp hour lithium iron phosphate battery from Ampere Time. It's got a built-in battery monitoring system that's going to help things keep from being overcharged. As you can see, it's very tight, very compact, and the beauty of this is you're going to be able to easily keep this. With some of the larger batteries, like the 100 amp hour and so on, may not be easily liftable. Now, the next thing we're going to do is get involved with a battery charger. Now, this looks like a power supply, and that's essentially what it is, but because of the BMS or battery management system in the lithium iron phosphate battery that we're using, it will shut off the ability of the battery to take a charge and help you keep from burning out a battery. Now, the other thing that we'll look at is an inverter, and this is what's going to take the DC power in the battery and convert it to AC. And as you notice with this one, there is the ability to charge your phone, or it's only got one USB port, but we'll address that in a later video as some options to look at there. So you can certainly have quite a bit of flexibility to get this up and running. Now, we're also going to have a fuse block. Now, the inverter will be tied directly into the battery, and that's because the inverter has its own set of fuses, so there's really no reason to double fuse the connection unless you just really want to be cautious. But as you can see, there is, let's see, 12, there's 12 connections on here. You got to make sure that you don't overload the battery, so you'll have to kind of do some calculations to make sure that you're not putting more load on the battery than what it's meant to handle. Now, those two rows of screws up top are what are going to be called a negative bus bar. So all your black cables or your negative connections will go into a common bar. That way way, when you hook up your individual positive connections, the red cabling, then you can have those individually fused. So if you need to yank one quickly, you can pull the fuse, or if that device has a problem, it should only blow its fuse and not the others. You may need to get some additional tools if you already have these. First, you want to start off with a good pair of wire cutters. And when I say a good pair, one that's meant to cut the heavy cabling, because you're going to be dealing with either 10 or 12 gauge wiring. And if you've got an old pair of pliers, they're probably not going to be that good to cut it. So you want to make sure you can get a good clean cut on all the wiring, because you're, for the most part, should be dealing with stranded wiring, and you want something that's going to be easy on the hand. So having these cushion grips will make it a little bit easier for you. Not that expensive, but it's also a good tool to have as you move forward with this kind of project or other projects as well. Now, the other thing you'll want to get into is a pair of wire strippers. Where this becomes important is, you see there on the left side of the screen, you'll actually put the cable in there and it will take away the insulation, and it should not cause any of the wires to be prematurely cut in the cable, because the more wires you cut, the less amperage it's going to be able to carry. Again, this is a good tool to use. If you don't already have one, definitely going to be easier when you go to put the ends on. Speaking of ends, you're going to need to get a supply of those. You'll primarily be using the ones for 10 or 12 gauge wiring, but you will find other uses, especially in a smart home situation, for these other ends. So that you want to tie them into a fuse block or other power source, that you've got things a little bit easier to work with on that end, instead of having to use a bunch of bare wires and then having more wire strands break. This last section is going to be some tools you should really think about having if you don't already have some of these, because this is going to help make testing the PowerStation or Powerwall or UPS even a little bit easier. So the first thing that we'll want to look at is just an AC tester. You can plug right into the outlet and it will give you the proper voltage that's coming out. So this will give you an idea also if you've got a wiring problem. But the main thing we're looking for in this tester is that it's got a way to showing the AC volts, because there may be times when getting to one of the individual wires may not be easy. That's where the clamp meter is going to come into the picture. This is not just a regular clamp meter. Most of the clamp meters that I've found have a limitation. They will measure AC only. Well, with this one, it will measure AC or DC through those jaws. The thing to remember, if you've never used a clamp meter before, you need to be around a single wire. If you just clamp it over an entire cable, your reading will be useless if it even gives you one. But this is where, as we're assembling the PowerStation, we'll be looking to test at different points, to verify that we do have power going through, but also that we're not pulling too much. Again, this can go with AC or DC. The nice thing is it uses just 2 AAA batteries, and they do send you a set, so that's going to make it rather handy as well. Now, for the times that you need to test the amperage on an AC connection but can't get the individual wires, a tester like this from the folks at X-Tech will give you that option. Now, the X1 and X10, that's going to be how much power is presented to the clamp meter. So you can start out with X1. If you're not getting any discernible readout from your testing device, you can go up to the X10 one, and it will give you that, what the X1 gave you, approximately 10 times more, so you can see just a little bit more. Again, these are all tools that will be well served for you to have in your toolbox as you start putting together the PowerStation. Well, they say a picture's worth 1,000 words. With the number of pieces, parts we're going to have in this video, I thought it was apt to show you maybe a little different way of looking at it, and maybe it'll help kind of everything fall into place. So let's switch over here to the Intel NUC, and I've got a new drawing tablet we're going to give a shot at here. So let me get the cursor located here. So the first thing we're going to have is the battery. Now with the battery, just like a car battery you're used to, it's going to have a positive terminal and a negative terminal. Now the first thing we're going to get hooked to all this is going to be the inverter that will let us take the DC power that the battery has, and we're going to turn it to a certain extent into AC power, although there will still be some DC available. So with the inverter, we will have one connection coming to here, to the positive terminal, another connection to the negative terminal. You saw me use a fuse panel, and we're going to get to that. But with the inverter already being fused on its own, didn't really see the need to have a double fuse connection. Once we've got that part hooked up and running, then we can go on to the next step, which will be to get the fuse panel installed. So the fuse panel, just to help you remember, there's a section up here at the top that where all the negative connections will go, and there's one terminal here, and then down towards the bottom there is the plus or positive terminal. we'll run a cable from here to the negative terminal, and we'll come out of the positive terminal and come in here to the bottom. That's going to set the stage. We've got, remember, there's 12 connections here. I'm not going to draw all 12 out. What we'll do is the next thing we're going to do is hook up the power supply. So we'll just draw kind of a rough block diagram here. From the positive terminal, we'll come out and we'll go to any number of the connections we got here. It doesn't matter which one you pick. It's a matter how the wiring is going to work best for you. So what we'll do is we'll take then a cable from the negative or minus terminal, and we'll tie it into any number of one of the screws up here on the fuse panel. Once you've got that in place, then you can go ahead and put a fuse in here. Then you can start charging the battery, assuming it's to that point. And I found some information that we'll be able to see how well the battery is in terms of its state of charge. So the inverter is going to be cabled directly in, and we're going to cut the connections off of that one and then just put terminals on and go in. Then the charger or power supply, I'm going to use the terms interchangeably, will then go into here, then go on. Now we'll be using several different test tools. At the inverter, one of the outlets that's right here, we'll use that plug-in outlet tester to make sure that AC is coming all the way through. This is going to be DC back in here. So we'll use the DC clamp meter, and we can verify that we've got power coming. We'll probably go with the positive lead. We'll be able to verify that power is coming from the battery to the inverter. So if for some reason the inverter doesn't power up, we can at least make sure that the power is getting to it, which is a valuable test step to have. And then we'll do the same thing with the power supply or charger, that once we've got it turned on, we'll be able to see what kind of amperage, probably voltage, but right now I'm looking at just the amperage, and that will get things going. That's where we're going to take this particular piece. There's other things that are planned, but this is pretty much the starting point to get you to where you've got a power station, and eventually we'll tie in a solar controller, and that way you can also charge it from solar as well. So we'll have a variety of ways to charge it. Now we're going to get to the point where we start putting things together. Now I'm going to take a little bit different approach on this. Instead of just trying to hook up everything and mount it in the milk crate day one, I'm going to get things working outside of that so that when we do move to the milk crate or whatever system you're going to mount this in, that you knew it was working before you put it in. So in case something stops working, you've at least got a point to go from in terms of troubleshooting. So let's switch over here to demo cam. See, I've got the 50 amp hour Ampere time laid out. I've got the inverter, got some connectors we're going to have. Now this is the cable that came with the inverter. So we're going to go with that one. I've got my clamp meter, and then I've got an AC meter, and then we've got some other tools that we will use here at some point. The cable that comes with the inverter is going to hook up right to these two poles. So what we're going to do is I'm going to undo this cable, and at this point we're not going to cut these ends off because this is already a good cable. We're just going to reuse the connectors at some point. What I would suggest doing is never hook them both up at the same time. So what we're going to do is hook up the cables to the inverter. So we'll first start with the negative. Always a good practice to start with your negative terminal first. That way you'll have everything grounded's not the right term. That's just where anything I've worked with DC power, I've always gone with the negative first. So we've got that. Then we will go over here and we'll clip onto the battery. We'll actually have to clip from above to get this to hold right. Then we will take the positive cable, get that tied back down here. This may spark a little bit. We'll turn on the inverter. See, we did have a little light come up there. That's good. Now we'll take some of our test tools because I'm going to test this at every point in the process. Okay, we'll verify that AC voltage is coming out, and see right now, if you can see it, okay, it's about 118, 119. Okay, so that's fine. And now that we've got a load on there, we'll turn on the clamp meter and we'll turn it down to 60 amps, which is what we need. It should be at DC, and you can press the Z/F button, and let's see what we've got in terms of recorded pull. So it is pulling a little bit. Let me get it over here where you can see it. Not pulling a lot, but that should drop down to 0 once we turn off the inverter. So the inverter is still drawing just an ever so tiny amount, but that at least tells us that it's working. So that's a good first step. We know that the cables are there. So you want to take this one step at a time before making any changes, and that way you'll know where the problem is. So we verified that the inverter to the battery is good. And remember, we're hooking the inverter straight to the battery because on the back of the inverter, it's already got its own fuse system. So we don't really need to run it through the fuse panel. Also, and I'm going to plug the cables back in here, make sure that you read all of the documentation that comes with the battery. And yes, Virginia, there is documentation, because what you'll want to do is look at it, and this will give you a and I'm saying it's a rough idea of the state of charge. So we've got that, and you'll just watch okay, now see someone about it's going to, depending on how I'm holding it, about 1305 or so. And if you consult the documentation, it gives you a very rough idea as to the state of charge. Now, a possible upgrade that we're going to look at later is actually putting an SOC, or state of charge meter, into the equation. But that's down the road, mostly in part because it's delayed in shipping with the holiday. So that will be one of the next videos that I put together. So let's go ahead and cut the ends off. Now, don't cut them right at the end. Give yourself a little bit of wiggle room, but I'd say cut it, a few inches down, so that way if you want to reuse these, then you can. So we'll first unhook the positive, then the negative, so we're completely disconnected. And I've got a couple of tools here, so we're going to get the cable stripper. And if you don't have some tools already, you will be getting this by the time you get through. So we're going to go down here. We will cut this right about there. We're not going to have it too long, but it's still going to be enough because we don't want to have this too far from the battery. I had to go get some new lugs because the ones I had were not large enough to fit over age gauge wiring. Now, I've gone ahead and stripped off this one. We'll go back to the other cables working on in just a second. Make sure you slide over some heat shrink tubing to be able to properly cover this connection once we're through. And I put the smallest lug on that I could. I'm just going to carefully spin it around so we try not to get any wiring out there that isn't supposed to be. Got that on there, and I've already got some heat shrink tubing. You'll see why here in just a second. And we'll just carefully and slowly crimp that on there and squeeze the handle all the way down, and then it will release when through. And see, now we've got that firmly attached. Now I've got the wiring all the way up in there as far as it would go, but what we'll go ahead and do is I've got a butane powered soldering iron. I put the end on here for the heat shrink tubing. Looks like that's there, so we'll just put it along the end here, and we'll just get the tubing all shrunk up. And no need to cook it until it changes color, but you can see that's got everything, just an additional level of protection to keep the wiring all in here. So we'll bring our negative cable over here. We'll do the same thing. You see, I've already gotten that one crimped, and we'll slide up the heat shrink tubing. And if you don't have, you can use a kitchen match if you have another choice, but I found something like this works a little bit better. And then it just takes just a few seconds here. All right, so that's okay. So that's got that all covered. And anytime you use something like this, always leave it off to the side to make sure that everything gets cooled down, because this part's going to be very hot right now. So we'll set it off to the side here, and it'll be cool down here in just a minute. Now, since we've made a change, we want to go ahead and retest the cable, because we have put connectors on. Everything should be fine, but we don't want to take any chances, so we're going to get this reconnected here. And like I mentioned earlier, we always will hook up the negative or black cable first. And you may see some videos that will say, oh, you can use any color wiring. It's always good to use color-coded wiring, because that way it helps make the process a little easier with troubleshooting positive versus negative. And I'm a big fan at making troubleshooting easier. So we'll get this reconnected, loosen this one up, and get that under here. And the first time you hook up your inverter, it might spark a little bit when you hook one of the connections into the battery. But it should be whatever the last one you do, which in our case is going to be negative, or would be positive. I don't know why I said negative. Okay, so we'll turn on the inverter. You should have heard the beep. So we've got the light there. If you want to, you can go ahead and retest the electrical. Certainly is not a bad thing to do. See, 119, so 118, 119. Okay, we're good there. So I got one of these little gems off Amazon, not that expensive, and we will plug it in. Of course, now because of the way it's oriented, it's going to be upside down, but you can turn it over quickly and see that it is putting out 5 volts. Nothing drawing on the end here, so we really can't see there, but at least this does tell us that we're getting 5 volts out at the connector. Now is when we're going to hook up our fuse block, fuse panel, whatever you want to call it, to our equation. And because the easiest way to handle this is probably going to be put it on top of the battery, since when we put this in the milk crate, and right now we're just kind of doing a trial fit on things to make sure that everything's going to go all right, we're just going to have it on top here, and probably we'll just keep it on top of here. So we will undo this, and we'll get, sometimes cables just don't want to go where you want them to, but we'll get that on top of here. Okay, had to stop things and get a pair of pliers that would let me get these nuts undone. Now I made these cables just like I did the other ones as things are flying off the table here. And I used heat shrink connectors on these and used that little butane soldering iron, which has a air piece on it to get the heat shrink down where it would hold things down. I'm doing this with 10 gauge wire, and it's mainly because it's the main connection into the battery. And really, for what the power we're looking at, shouldn't need to use anything heavier than that. Now we'll hook up the positive off of the battery. I'm trying not to have everything go flying. Well, we'll just put these both under here. At this point, just finger tighten things. While we're doing kind of the test fit and getting everything wired, don't try to really tighten things down, or you may have some challenges getting things loose. Now, also on the fuse block, do not put any fuses in at this point because it's way early in the process and we really don't want to have anything fused, so that when we hook up the positive side of a connection, that we're not going to have something live that could be a problem, or you might even get a shock out of it. So again, at this point, we'll just put that in and just finger tighten it, and we'll add the fuses as we need to. Now we're going to be hooking up the power supply into the fuse block. So I've got all the cabling already made. You're going to have to take just a regular 3-wire AC cable and just cut the outlet end off it to where you leave just the plug. And you don't want much out here because you don't want a long cable hanging out of your power station. So I've got all 3 ends crimped, and I had to use the crimp connectors that they sent with this so that I could get the different wires in there. Yes, you could put the bare wires in. I would not, just because you don't want something shorting out. At least this way it keeps them from doing that, and it gives a little more support to the wires, because I've got them in there pretty well crimped. I did not put on additional shrink wrap tubing. That's certainly an option. Now you notice I've got the red and the black is going to go to the fuse panel. Those are already connected, and the labeling you see on there pretty much tells you what you've got to go do. So, and you can look up the codes or the colors for the AC wire. Mine used a little bit different coloring. So basically the load or the hot wire would be coming in on black for the cable that I've got. Neutral would be white, and the remaining wire became the ground. You can check that out with your voltmeter. So let's go ahead, and the first thing we'll do is we'll hook up the positive wire to here. Then we'll hook up the black wire to one of the bus bar connections up here, because all the negative is going to be common. And let's get this turned around so it's right side up. And you see the little LEDs come on because it's already sensing that there is an unfused connection there. So it's just alerting us that it is seeing the power. So that's good, but we're not going to do that. Not going to hook it up just yet, because we're going to connect the AC for the power supply, and I just bent over a connection I've got in the area, then it got nearby. So you see it says, well, here, let me get this turned out of the way so you can see that. So it's showing right now 13.8 volts, but we want to dial it up to 14.4, and it's just going to be a little, just take it very slowly. Okay, so 14.3, 14.4. Now I don't want it 14.5. Okay, come on. Okay, 14.4. Okay, got that one right. So since this cannot supply any more than 10 amps, you got a bag of blade fuses that came with this, so we should have a 10 amp in here. And here's a 10 amp. Probably could go to a 15, but since it's a 10 amp supply and that's what it's rated for, if it crosses 10 amps, then that's where we want it to blow if it were to cross 10 amps. So now we'll just put the fuse in. Now see, the voltage did drop just a little bit, which is what we expected to, because it's actually now starting to charge. So let's verify what we've got here, and we'll turn our clamp meter back on. It's set for DC. Okay, it is showing, well, it says 11 amps, but there's always a little bit of margin for error. So that is charging. Now, if you were ever to put the clamp meter on here and not see anything, then it's a good indication that the battery management system. And see, we're going up on the positive wire. I'm sorry, you can't see that one. Let me get this over here where you can see a little bit better. We'll clamp here on the negative. We should see. Okay, so see now that's showing right at 10 amps. And that's what's coming off of the power supply. So that's good there. That says double checked all my connections. All that looks good. And we can turn the inverter back on. It should pick up that it's okay. It's pulling, you can't really see it, but it's displaying, nominal power because it's not really pulling anything, but we know that that's working. This is showing. So now we've got a workable power station. Whether you've watched through the entire video or you've been following along building your own power station, you've now got a functional system. But a few things we need to go over just to be on the safe side, and that's going to be on the power supply. There is a label that you will see right here, and mine is now gone. It's actually laying over here. You need to make sure that you set the proper line voltage. So most folks, it's going to be 115 if you're in the US. If you've got it on a 220 circuit, that's fine. That means it's going to work less strenuously because it's got higher voltage coming through, but that's a whole nother discussion. But make sure that you do that. And there's also at least with my battery, the ampere time, there's a whole set of instructions and documentation that comes with it, and it gives you some very interesting information to how to manually check the battery for the state of charge if you don't have a state of charge meter connected to it. And we will be doing that in the next video. Everything that I was waiting for finally has shown up, so we're going to be doing that as well. Now you're going to see me leave everything pretty much out in the open here the way it has been, because it's going to be easier for me to work on and for you to see what's going on. And then the very last step will be, once you get everything up and running, then to mount it in whatever sort of milk crate, egg crate, whatever you're using to containerize this all in, and then go through all the steps of checking sure that you've got voltage and amperage in place. Really hope this video has been of value to you. We're going to be doing some other things in this area, doing a little more hands-on and taking you through the steps of what's needed to do your own power station. I may even look down the road at adding a second battery, because I'm not going to, the 50 amp battery that I've got is still more than up to the job I'm going to be using it for. So there's no reason to really change it at this point, but certainly adding a second battery for capacity would not be a bad thing to do. If you're watching this on YouTube, you're going to see videos on the screen that are similar to the ones you've just watched, or other content that YouTube thinks you might be interested in. If this video helps you or provides value, please click on that like button, thumbs up. If you haven't already subscribed to the channel, please click on subscribe now and enable notifications. We'll see you in the next episode. Thanks for watching.